In the last video, we saw about enhanced cloud architecture, right? This is the diagram about that architecture. So why we came up with this architecture? Because the simple cloud architecture had some single point of failures, and we addressed with the cloud load balancer in front of the VMs and two availability zones to take care of the failovers, and a cloud load balancer in front of DB instances, and also the web application firewall to take care of the DDoS attack, right? And I asked a question about this architecture, whether this is complete architecture or not in the last video. The answer to that question is no, because of the following factors. Okay, think about a scenario where your application is going to serve all your customers during the peak volume day. That means like during the Black Friday or New Year day or any festival day, usually the volume of requests to your online application is higher, right? So can this architecture handle that situation or not? That's the question. The answer to the question is partially it can handle. Let's say like your application is receiving millions of requests per hour, and your cloud load balancer will distribute to the two instances of virtual machine where your application is running. But in case if one instance fails, it will all the requests will be redirected to the second instance. But think about a situation when the second instance also receive a lot of requests, this will also fail, right? So your customer's request will not be fulfilled. So how do you handle this situation? And also, like in case of DB instances, your request will be reached to the cloud load balancer, and assume a scenario where your DB instance 1 is failed, so all the requests will be sent to your DB instance 2. But if your DB instance 2 also fails, what will happen? The system will go down, right? So to handle this situation, we are going to see two important factors. Okay, the one is like serverless and second one is stateless. Okay, so what exactly the serverless is? The serverless is nothing but in case if you are in the process of provisioning your virtual machine in the manual way by logging into your cloud service provider console and clicking on a button to select your image and configure your memory and CPU and pick one virtual machine to spin up, right? So this will take a particular amount of time to spin up your virtual machine. So every time when the peak volume scenario happens, that single virtual machine will fail, and it will go to the second virtual machine. And if this also fails, you cannot log into your cloud service provider console and spin up another virtual machine to handle all those requests. That's practically impossible, right? So to handle that type of situation, this serverless concept is available in all the public cloud service providers portfolio. Okay, so basically what exactly the serverless is? So serverless is nothing but a function as service. Basically it will have a simple script file where you can define the threshold to create virtual machines automatically without any manual intervention or manual provision. Okay, so basically that is called function as a service or FaaS. So in that script file, what you can do, you can define your threshold. For example, when CPU of virtual machine 1 goes above 90%, spin up another virtual machine. Okay, or the memory of the virtual machine 1 goes to above like 80%, create another virtual machine. So in this way, during this peak volume day, you don't need to touch the system, right? It will all be handled by this function as a service or function, and your virtual machine will get spinned automatically. So you can apply this serverless function in front of your virtual machines, also in front of your DB instance where your DBs are running. Okay, And the second concept that will help you to scale, provide your system as a scalable system is stateless. So what is stateless? Basically, when your system receives a request from the customer or client, it may store the request and process the request and get the response back. Sometimes it may store the response also, or it may store the state of the request. So when it stores the state of the request, basically your application will grow gradually, and it may end up in a crashing situation. So to avoid that, you have to write your applications using microservices. Basically, microservices are stateless in nature, and also since microservices are stateless in nature, it is very much suitable for containerization. Okay, so when you implement this serverless and stateless in your system will be a perfect system, and it can handle any type of volume, and it will survive in peak volume days. Okay, so in order to give you a evolution of the cloud architecture, I showed these three diagrams. Like initially we created a simple cloud architecture where it had many single point of failure. Then we addressed those single point of failure with all the load balancers and also like cloud load balancers, right? And even after addressing all the single point of failure, it was not that scalable, right? So we introduced the scalability with the third diagram. So our evolution of cloud architecture started from simple cloud architecture, and we moved that to enhanced cloud architecture, and from that we reached a steady state or perfect state or ideal state of the architecture, cloud architecture, called scalable cloud architecture. Okay, hope you might have got a good idea about how the cloud architectures are enhanced and scalable by using different functions available in each cloud service providers, right? And I have given this article in detail in my LinkedIn newsletter. I have given the link below in the description. You can read through and enjoy this content. And if you like this video, give a thumbs up, subscribe to my channel, share this to your friends to help them to understand the cloud architectures. Take care. Bye.